All right, we're going to be learning about the chain rule today. So, pretty important rule that's going to carry on the rest of calculus here, just like product rule and quotient rule. So let's get to it. So we have a function where you have a function inside of a function. Okay. Then the derivative of that is going to be f prime inside the function times the derivative of the inside function. Okay. So let me kind of clarify what this is. So if you notice on your screen on the bottom right, you're going to see a picture of some blow pops there. Okay, so the reason is because I'm going to name a function as f of g of x. And I'm using these colors in particular. Let's say that this is just some function. So I have, just like a blow pop, the outside of the blow pop on your screen is the green one. The outside is green. Okay? And then the inside is pink, and that represents the bubble gum. So when you are finding the derivative and you're changing the outside of the blow pop, does the inside change at all? No. As you're eating the outside, the inside stays the same. So that's why it's going to be f prime of the inside stays the same. Okay. And then after you're done with the outside, then we start working on the inside, and that's when you start eating the inside that the inside starts to change. Okay. So chain rule is like eating a blow pop. Here it is. The outside is that green sugar coating, and then the inside is that bubble gum. You start first eating the outside, so the inside does not change, and then when you're done with that outside, you have to start changing that inside because you're going to start eating that part as well. Okay? So what does that actually look like when we get to here for this? Well, here's your function. Now we need to do chain rule. You know that because you have a function inside of a function. So the first thing we're going to do here is I want to rewrite this actually so you can kind of see. I'm going to color code it. So here's my green sine e to the x. So now I'm going to change that outside. So the derivative of sine is cosine. So I changed the cosine. Again, this is when I'm taking the derivative, by the way. And then the inside stays the same. Okay? And now, what's the derivative of the inside? Derivative of e to the x is just going to be e to the x. Okay? And that's chain rule. Now, what if we wanted to find the second derivative? So we'll just write the directions up here. We're going to find y prime and y double prime for this one. I don't do it for all of them. I'll just do it for this one. Okay? So we find y double prime. We're going to have a little bit of product rule here. I have a function right here. This cosine e to the x is the first function, and e to the x is the next function. So when I take the derivative of this first function, this is actually a chain rule. So derivative of the outside is going to be negative sine. Inside stays the same. Times the derivative of the inside is e to the x. Okay. That was the chain rule of this guy right here. Since it's product rule, you take the derivative of the first, which I did, leave the second. So now it's times e to the x, plus leave the first, times the derivative of the second, and the derivative of the second is just going to be e to the x. So all of the colors there, that's the chain rule going on. Everything else is going to be just product rule. So now we can clean this up a little bit. So it looks like we have a GCF here of e to the x for both of these. So this is going to be e to the x, and then you're going to get negative sine e to the x, and this one has an extra e to the x, plus cosine of e to the x. Okay. Again, I didn't have to do this part, but I just did for giggles. All right, moving on here for this next one, we'll just find y prime. So let me rewrite this so that we can color code this, because I have two functions. I have my outer e function. So it's going to be e to the secant of, actually I have an inner of the inner. And we'll let brown represent Tootsie Roll. So, and that's a very special lollipop. You have that green candy coating on the screen. It's delicious. Then you have the bubble gum. And then inside that bubble gum, you have some Tootsie Roll. Delicious. Okay, so to do this, you're going to take the derivative first of the outside of the green candy coating. So what is the derivative of that green candy coating? It's going to be just e to the whatever it is. So it's going to be e to the, and then it stays the same. So this is going to be e to the secant of 3 theta, okay, times, I have to do the derivative of the pink. What's the derivative of secant? Anybody know? Its derivative of secant is secant tan. So times secant tangent, and then the inside stays the same. Times, and now the derivative of the brown, which is the Tootsie Roll, is going to be derivative of 3 theta with respect to theta is going to be just 3. So as you can see here, since there's 3 functions, e, secant, and then the 3 theta, I have 3 things. So there's the e, there's the secant, and then there's the 3 theta part. Okay? So if you want to just clean this up and make this look a bit nicer, I'll just put that 3 in front, and that's really all I'm going to do to make that look nicer. Okay? All right, and then our last example, by the way, I'm going to need to remind you how to find the derivative of this function right here, and this is on your formula charts. You are expected to know how to find the derivative of that. Okay? So if you want to find the derivative of a to the x, that's going to be a to the x times ln of a. So you are expected to know that. So now when I rewrite this as my 3 functions, I have 3 functions again. I have the 2 to the whatever, then I have the 3 to the whatever, and then I have x squared. So when I rewrite this, I'm going to get that green candy coating is the most outer one, 2 to the 3 to the x squared. So those are my 3 functions that I do have. So to find y prime, that's all I'm going to ask you to do here. I'm going to get y prime equals, so the derivative of that 2 to the stuff is going to be 2 to the, and this all stays the same, 3 to the x squared times ln 2. Derivative of the pink there, the bubblegum part, is going to be 3 times 3 to the x squared, and I'm going to do that, to the x squared ln of 3 times the derivative of that brown, the Tootsie Roll part. The derivative of x squared is just going to be 2x. And that's all of that, all right? If you're not a fan of all the colors or whatever, so I'll go ahead and rewrite it for you right here. We're going to get 2 to the 3 to the x squared times ln of 2 times 3 to the x squared ln of 3 times 2x. And right there, that is your final answer with all of that. This will be the only set of notes that I'm doing these colors and stuff like that. You do need to get familiar with chain rule. Really recognizing when you have a function inside of another function is the big deal for this one. Once you recognize it, it's not that bad to go through these. Sometimes you have function in a function in a function, like these two. Sometimes you just have just one function in the other. Okay, and that's all.